Okay, so it's time to move on with our matrix operations here. Yesterday, we talked about scalar multiplication with matrices, adding and subtracting, and then using those ideas with solving equations with matrices. So today we are going to do multiplication, and multiplication involves quite a bit more work than just adding and subtracting. There's a little bit more to it, and there's a little bit more rules that go along with it too. So with matrix multiplication, just like adding and subtracting, the matrices must have the right dimensions. They don't have to have the same dimensions, they just have to have the right dimensions, okay? And I'll show you how to know if they have the correct dimensions to be able to be multiplied together. In order to be able to be multiplied together, we think about it as what is the dimensions of the two matrices that are being multiplied. And in order to be able to multiply them together, if one is a 4 by 1 and one is a 1 by 5, in order to be able to multiply them, these two in the middle have to be the same. The number of columns in the first matrix and the number of rows in the second matrix, have to be the same. And then the resulting matrix is going to be the outside. So if we have a 4 by 1 and a 1 by 5, the resulting answer is going to be a 4 by 5. If we have a 3 by 2 and a 2 by 3, okay, so these two match in the middle, our result is going to be a 3 by 3. If we have a 2 by 6 and a 6 by 4, these two repeat in the middle, our solution will be a 2 by 4 matrix, okay? So that's how we know if it's even possible. If these two in the middle do not match up, then it is not possible to multiply, and we'll just write undefined. Okay, so let's take a look at how we would actually multiply together and the rules that we need to follow. So we have these two matrices. I've got this guy here. Again, I'm going to put him in our brackets like we like. Okay, this one that we start with is a 3 by 3, right? So we have a 3 by 3 matrix, and we are multiplying it by a 3 by 1. First thing I notice is, yes, we can multiply it, and that our answer is going to be a 3 by 1 matrix. So our answer is going to be a 3 by 1 matrix. So we are going to find C times D. Okay, so I'm going to write that down here. Okay, I'm going to do C, which is 7, -2, 4, -1, 6, -7, 4, 8, -2. We are going to multiply that by our 1, 5, -4. Okay, so we know our solution is going to be a 3 by 1 matrix. Okay, so I'm going to give myself a little bit more space over here to show my work. Okay, so my solution is going to be a 3 by 1, and I'm going to make some space to show my work. Okay, so in this matrix, here's how it's going to work. We are going to take row 1 times column 1. So we are going to take, and I'm going to highlight in the top up here so that it's easier for you to see and it doesn't get in the way of my work. But we are going to multiply row 1 times column 1, and that is going to give me my top row answer. So when we do this, we multiply like the corresponding parts, and then we're going to add them all together to get that first row. Okay, so what we're going to do is we are going to take 7 times 1, that's row 1, column 1, like first, so we're going to take 7 times 1 plus, then we're going to add it to, we have a -2 and we have a 5. So we're going to add that to I'm going to need a pen, -2 times 5 plus, then our third one is going to be that 4 and the -4. So we are going to have 4 times -4. And then we're going to actually go back here in just a minute and we're going to calculate that out to see what we get, but we're not going to do that just yet, okay? Then the next thing that we are going to do, okay, so the next thing we are going to do is we are going to take row 2 times column 1. So we are going to take this row times column 1, and it's just going to be the same thing. The first in the row is going to be the times the top, the middle times the middle, and the last times the bottom. So we're going to do the exact same thing that we just did, except now we're going to do it with row 2. So we're going to have -1 times 1, which is -1 times 1, 6 times 5, plus -7 times -4. Okay, and then we're going to go back here in a minute, and we're going to evaluate what that is. And then our last row that we're going to use, we're going to do the same basic idea. So I'm going to pause here for a second and erase my stuff up on the top. Okay, so then the last row is going to be what we get when we take the third row times our first column. So we're going to do that. We're going to take, again, the first times the top. So we're going to have 4 times 1, 8 times 5, and -2 times -4. Okay, that's going to have to scrunch in there just a little bit, but we get a 3 by 1 matrix. Yeah. And for the sake of space, I'm going to put the answer to my 3 by 1 matrix a little bit out of place here, but when we combine this row, when we add those up in our calculator, I'm going to put my answer up here, we end up at -19. That's our solution for the first row. And then when we multiply and add that row together in our calculator, we're going to get 57. And when we add or multiply and add this bottom row together, we are going to get 52. So there's a lot of like just little attention to detail things on how you actually multiply and stuff. What row, what column. Starting out simple, we did a 3 by 3 and a 3 by 1, so that our solution was a 3 by 1 matrix when we got done multiplying. Okay, so let's just try a couple of more here. Okay, so again, I am going to put our things around our corners here. Okay, this one first, matrix A is a 3 by 2. Okay, matrix B is a 2 by 2. So our solution, these match, so we know it's possible. Our solution is going to be a 3 by 2 matrix. Okay, so let's go ahead and show what we're going to do here. So I'm going to have A is going to be -1, 3, 4, -2, 5, 0. There's my A. And I'm going to multiply it by B, which is -3, 2, -4, 1. Okay. Kind of like before, I am going to use highlighting up in the top original problem that we had typed in there in order to see where things are coming from. Okay, so I know I'm going to have a 3 by 2 matrix, so I'm going to have a row 1, row 2, and a row 3, and I am going to have 2 columns. Okay, and I'm going to just put a little dashed line in between here. This is column 1, and this is column 2. Okay. So if we think about it, kind of like when we do the box method or anything when we multiply, that's kind of how we could think about it. To get this information right here, we are going to take row 1 of A times column 1 of B. And we're going to multiply the coordinating pieces and add them up. So that means I would have -1 times -3 plus 3 times -3, 3 times -4. Okay, that's going to be for that column. And then we're going to kind of do the same thing. I'm going to work my way through here. Now I'm going to take row 2 times column 1, and that's going to go here. So I'm going to have 4 times -3 plus 2 times, or excuse me, -2 times -4. And then down my next one, I'm going to have to erase some of this a little bit so you can see my colors a little bit here. And then here, I'm going to take row 3 times column 1. So I'm going to have 5 times -3 plus 0 times -4. Okay, and again, those values are going to be what's in my first column. And then I have to probably scooch this guy over a little bit so I have a little bit more room to get that second column in there. All right, so now let's erase up here. Okay, so then now I'm going to find row 1, column 2. So I'm going to take row 1 of A times column 2. So that's where these numbers are coming from. So I'm going to take row 1 times column 2, and I'm going to have -1 times 2 plus 3 times 1. My next one, I'm going to take row 2 times column 2, which is going to be 4 times 2 plus -2 times 1. And then that bottom one is going to be row 3 times column 2. So I'm going to have 5 times 2 plus 0 times 1. Okay, so then our final solution, again, I kind of ran out of room just a little bit here, but it's going to be a 3 by 2. My first column, I'm going to use my calculator to calculate that part right there, and it should give me -9. If I use my calculator again to calculate this part right here, I should get -4. If I use my calculator to find this part right here, I should be at -15. So my first column is -9, -4, -15, and then my second column over here, do a different color. If I use my calculator and calculate those right there, I should get 1. If I use my calculator to find those, I should be at 6, and then 10. So when I multiply these two together, I get my first column, -9, -4, -15, 1, 6, 10. Okay, and then just moving on to this next one, this one will be very quick because I know that this is a 1 by 3 and this is a 2 by 2. Since these do not match, we would call this undefined because we can't actually multiply them together. Okay, so we can look at another one here. Actually, I'm going to skip this one. If you want to pause the video, try it. I would highly recommend that. I'm not going to go through all of the steps on how I solved it, but I will tell you, pause the video, and I'm going to write down what the solution is so you can see if you did it correctly or not. Okay, again, if you did it correctly, your first column should be -3, +3, -5. Second column should be -22, +10, +10. And last but not least, we're going to do a little application where you can use matrix multiplication to find out how much things cost and things like that. But you have two softball teams that submit equipment lists to their sponsors. It has a men's softball team and a women's softball team. They each get bats, balls, and gloves. Each bat is $80. Each ball is $4, and each glove is $90. Okay, so what we're going to do, all right, so I can just pretty much turn this into a 3 by 2 matrix. Okay, so I can turn this into a 3 by 2. So I have 12, 45, 15, 15, 38, 17. And if I want to find out how much each one costs, I'm going to use this information to write a matrix, okay, where I have $80, $4, and $90. And And notice it does matter the order that you put them. If you had put the 84, 90 over on the right side of that other matrix, it would not have been able to be multiplied. So if you have, this one is a 1 by 3, this is a 3 by 2. Your resulting matrix should be a 1 by 2. And that basically, your 1 by 2 is going to be your total equipment cost for women and men. Okay, so if you multiply those together, again, we can do the same idea that we did before. All right, so we would have, we're going to end up with a 1 by 2. So we have 1 row, 2 columns. Okay, so we're going to take row 1 times column 1. So we are going to have 80 times 12 plus 4 times 45 plus 90 times 15. That's going to be our column 1. And then our column 2, I'm going to have to overlap them just a little bit here. I'm going to take row 1 times column 2. So I'm going to have 80 times 15 plus 4 times 38 plus 90 times 17. Probably should have left yourself a little bit more room. So this is going to be column 1, this is going to be column 2. When you use your calculator to compile the green, you get that column 1 is 2,490. And then your column 2, when you add up all of your red, you should get 2,882. And what that represents, the $2,490 is the cost of the women's team to have bats, balls, and gloves. The $2,882 is how much it costs for the men's team to have the bats, balls, and gloves. So the thing is, you have to make sure, if you have a 1 by 3 and a 3 by 2, you have to make sure you're multiplying in the correct order. Otherwise, the dimensions will not match. So the order with multiplication and matrices does matter, how you do it. So there is a matrix multiplication worksheet that you need to work on and complete and submit. And there are also additional matrix multiplication examples and videos in Schoology, if that would help, if you want to watch any other lesson videos or anything like that. That's not my voice, that's fine. You can certainly do that.